Hello my dear grade 8 students. So earlier we discussed about the human organ system. That was a biological lesson. So here today we are about to discuss the 10th lesson in your grade 8 science syllabus. So the 10th lesson is reflecting about the electricity, and here especially we are discussing about several other things related with the electricity lesson. Now, I think that you could remember in the earlier lessons, we studied about the measurements related to the electricity. We studied about the voltage, we studied about the current, and we studied about the resistance of a conductor, right? So this is a further clarifications. These are the further clarifications related to the electricity lesson. So here mainly we are discussing about, right? So when you take electricity, we know that electricity is a type of an energy. When I was doing that previous lesson, I gave you a certain idea about electricity. I told you that it's a type of an energy that we used in our day-to-day life. By using or by utilizing electricity, we do different kinds of works in our day-to-day life. Like for an example, in order to boil water, we use the heater. So heater is operated through the electricity. For our entertainment, we use televisions. So the television is operated by electricity. So electricity is a type of an energy, right? It's a type of an energy. So the things which are operated from electricity are called electrical appliances. And the ones which we can use to get electricity, or the things or the instruments that can be used to get electricity, are called as sources of electricity. So like that way we discussed several things related with the electricity lesson in the earlier lesson, right, related with the electricity. So now we are discussing about further things related to this electricity part or this electrical energy. So my dear children, let's see what are the contents in this lesson that we are about to discuss. So first of all, we'll be discussing about the various methods of connecting cells and bulbs. By discussing first of all how to connect a cell with a bulb. How to, if you are given with several bulbs and several cells, what are the ways of connecting these things? How we can connect these cells together? So already when I was doing that previous lesson related to the electricity, we discussed that we can connect these bulbs or cells or whatever electric component by using two different methods as series and parallel. So here within this part, I'll be showing for you guys how to connect these things, and we'll be doing several practicals related to these things as well in order to show and in order to clarify the two connecting methods, parallel and the series ones, right? So like that we'll be discussing several things related to the connecting methods first. Then after that, in the second one, we'll be discussing about simple electric circuits. Mainly we are discussing about the torch, right? The electrical torch that we used in our day-to-day life when there is dark, right? And if you are traveling in dark, you know that you are going to use a flashlight. In simple, this is referred as the torch. Okay, so we'll be discussing how a torch is going to work mainly under the simple circuits. Then after that, we'll be discussing about current controlling components, right? Current controlling components. So especially current controlling components, we studied that we can control current by changing the resistance in a circuit, right? So resistance is the obstacle given against the flow of electrical charges, or in simple current, right? Against the flow of electrical charges, against the flow of current. The obstacle given is referred as the resistance. So more and more the obstacle, less and less the current flow. Even we conducted an experiment in the earlier lesson by using the nichrome coil, by using a copper coil or copper string, and by using iron string or else a steel string. We conducted even an activity. So if you haven't checked that lesson, check it and refer this one. So by that way you can get a very good knowledge about the two lessons related to the electricity. So the earlier lesson is really important in handling these or in tackling out these things. So remember, my dear children, to check the previous lesson, right? Previous lesson related to the electricity, lesson number 8. So it's been posted to your it's been already posted, so you can check that thing, and after that come into this one. So by that way you can get a good sound knowledge, right? So we'll be discussing after that about the household electrical appliances. We'll be discussing about household electrical appliances, right? Then after that we'll be discussing about the when you provide electricity to a certain electrical instrument, to a certain electrical appliance, you know that under the lesson changes in matter, we discussed that matter is indestructible, right? Matter is indestructible. Matter cannot be created and it cannot be destroyed. Only thing that can be done to matter is converting from one form to another form. In simple, this is referred as the law of conservation of mass. In simple, that means matter is getting changed from one form to another in any kind of a change. Their total mass is not getting changed during any kind of a change. It can be a physical change or else a chemical change. Whatever the thing, the total or the entire mass is not going to change at all. It remains the same. In the same way, my dear children, there is a concept in energy as well, which we referred as the law of conservation of energy. Like in the law of conservation of mass, we refer this thing as law of conservation of energy. Law of conservation of energy means, here it's stating that energy cannot be created, neither it can be destroyed, like in the mass thing. We can't create energy, we can't destroy energy. So the thing that we can do, right, for energies is converting one energy to a different form of other energy. For an example, you know that if you turn on the switch in your room, a bulb is going to light up. So by turning on the switch, you are providing electricity to the bulb. So by that way, bulb is going to light up. So in that case, my dear children, is the electricity is getting wasted, or is the electricity is getting totally converted into light energy? Actually, it's not converted. I'm asking about, is it being used, right? Is it getting destroyed? Actually, the thing which is going to happen, it's electricity energy is not getting used over there, right? It's like a troubling situation, right? When you're going to turn on the switch, you know that electricity is getting consumed. Otherwise, how we are getting bills, right? You know that some amount of electricity definitely getting used by the bulb. Actually, it's not getting used. Using means we are consuming. Electrical appliances are not going to consume, right? Consume energy. What energy? Electrical energy. These electrical appliances are not going to consume electrical energy. Then what are they going to do? They are going to convert these electrical energy into other forms of energy. Actually, any of the energies cannot be consumed. The thing which can be done to energy is, we can convert one form of energy to a different other form of energy. So we'll be discussing several those types of conversions that could happen when you provide electricity to a certain electrical appliance or in any kind of an instrument. So we'll be discussing about those things in here specially. So first of all, we'll be discussing about the heating effect of electric current. Here, specially we are discussing how does electricity is getting converted to heat energy. So I told you that electricity is never getting consumed by an electric appliance. It's never getting consumed. It's getting converted to different types of other energies. That's what happens when you operate any kind of an electric appliance at your house. Let's imagine that you are going to turn on the television. So when you are turning on the television, the electrical energy which is provided to the television is getting converted into light plus sound energy mainly. Okay, there are other forms of energies as well, but however, the two types of energies that we utilize are light energy and the sound energy. That's it, right? So when you operate a heater, right, electrical energy is getting converted to heat energy. So especially we are discussing about that effect carried out by the electric current under the heating effect of electric current. Then the next one will be discussing about light effect of electric current, the lightning effect of electric current. Especially we are discussing about the bulbs here, LEDs, right? Then after that, we'll be discussing about the magnetic effect of electric current, magnetic effect of electric current. So under the 6th lesson, I think that you have got a sound knowledge about the magnets, and we discussed that by providing electricity to a certain coil plus to an iron core, we can create out a magnet. So that magnet was referred as an electromagnet. So we can create electromagnets by using this property. Actually, the electromagnets are getting created by using this property. Here the electrical energy is getting converted to magnetism or the magnetic energy, right? So under the magnetic effect of electric current, we'll be discussing how to create magnetism by providing electric current. Then finally, we'll be discussing about the chemical effect of electric current. I think, my dear children, already you know about these factors. Like what factors? I think you know about what are household electrical appliances. I already named these things. What do you mean by household electrical appliances, right? We already did these things under the 8th lesson when we discussed in the last electricity lesson, measurements related to electricity. And we discussed about the simple circuits. Even we drew out the, right, simple circuits at that lesson also. Then we discussed about how to connect in node. Actually, we never discussed in detail, but however, you are familiar with these things. We did, like when we are discussing questions related to the last lesson related to electricity, we did some questions related to these kind of things, right? So however, you are familiar with these things, and also you know that heating effect of a current, right? You know about this thing, somewhat you know, and you already know about the lighting effect, right? You already know about the LEDs, you already know about the light bulbs, you already know about the torch, and you know that by providing electricity we can get light energy. Then after that, magnetic effect. Under the magnets lesson, we discussed this thing, but this is a very fresh part. You haven't learned about the chemical effect of electric current. Chemical effect of electric current. This is a very fresh new beginning for you guys in electricity part, right? All of these things we already know that by providing electricity we can do all of these things, right? Like what things? We can get heating effect. We can heat something. We know that by providing electricity we can light up some instruments. Then we know that by providing electricity we can create magnets. Then what do you mean by the chemical effect? The chemical effect. Chemical effect means, in simple, here we are providing electricity to a certain item or to a certain system in order to take a chemical reaction within it. So by utilizing that chemical reaction, we are making a new kind of substance that can be utilized in different places. For an example, have you heard about the plating of a metal? Like if you take a metal, right, you know that there are certain running instances or running events, right? There are certain running events, athletic events. So in athletic events, most of the times you'll be given with medals. So we know that one type of a medal is gold, the second type is the silver, and the third is the bronze. So if you take gold and silver medals in a running event, which are given to the winners, are they real gold and silver? Right? Are those medals are real gold and silver? Like you know that it's like this kind of a disc, right? A medal, this kind of a disc. So it should be very valuable, right? It should be like millions of rupees. But is it that much valuable? I'm just talking about the simple athletic events that's going to hold in our country, right? I'm not going to go in international level. I'm just talking about local things or events that we are going to hold in our, like in house meetings, right? Like in district level events, and sometimes in national level also. So however, I'm not talking about the international level, I'm just talking about the national level, right? Just imagine about the Sri Lanka, that's it. So in these events, are you given with those real medals? Actually, most of the times not, right? Most of the times you won't be receiving real gold medals. If you take the value of those medals, they are not going to worth billions of rupees. It's because that here gold or silver is being plated on the surface. It's not entire gold or entire silver. It's been plated. A layer of gold or silver is being plated on the surface. That's it. A very small bit of a coating. How can you plate it? Can you like dissolve gold in some kind of a solution and can you apply it like paint? Of course you can't, right? It's not a paint. You know that gold is a type of a metal, so we can't apply it like that way. Then how come you could apply a coating of gold? If you take a piece of copper, how can you apply a coating of gold in a piece of copper? Like let's imagine that you are given with a copper or else a brass cutlery, right? Then how can you plate, or else a key? So how can you plate a layer of gold or a coating of gold on that certain item? So my dear children, in that case, right, in order to plate gold or any other kind of a metal on a certain different other kind of a metal, we use the method called electroplating. Electroplating. Here we provide electricity. Here we provide electricity to a certain solution, right? To a certain type of a solution. We refer this thing as an electrolyte. So to an electrolyte, we are providing electricity. By that way, we can plate that particular metal what we need on a different kind of an instrument. So we'll be discussing about this part, right, in detail under the chemical effect of current. Especially here, you know that for a liquid, if you are providing electricity, if that liquid is going to turn into a different other substance, like you know that if I'm going to provide electricity, like in the earlier case, to a solution of gold, suddenly gold is going to appear from that solution. Now in the earlier case, let's imagine like this. If you take copper sulfate is a blue color. Copper sulfate. It's like a blue color substance, right? So by taking a solution of copper sulfate, when you are going to dissolve it in water, and if you provide current to that solution, you can deposit copper, or you can change or you can extract the copper part out of the copper sulfate solution. So my dear children, earlier it was copper sulfate. Now by providing electricity, you can change or you can extract the copper out of it. So earlier it was copper sulfate, now it is copper. Means new substances has got created upon providing electricity. So that means here a chemical effect means actually a chemical reaction is going to occur. So by providing electricity, even we can create out a chemical reaction within certain types of solutions or compounds or systems. So that's the part we are discussing about the chemical effect of a electric current. It's a fresh new topic, a fresh new part, a new idea that you are going to learn under this 10th lesson. So these are the contents that we are about to discuss within this lesson, my dear children. So within this lesson, we'll be first of all discussing about connecting methods. Then after that, simple electric circuits, current controlling components, household electrical appliances. Then we are discussing the energy conversions which going to happen, right? So by providing electricity, you can convert electricity to different other forms of energy like heat energy, right? Then light energy or light effect, the magnetic effect and the chemical effect and so on. Then after that, after finishing the lesson, as usual, we'll be discussing several questions related with the lesson, my dear children. So stay with me till the end of the lesson, right? And we'll go through each of these contents one by one, right? So let's start our first chapter related to the lesson. So here, first of all, we are discussing about how to connect or connecting methods related to a cell or else an electric component. So first of all, we'll discuss what are the things that we studied on the previous lesson related to the electricity mainly, right? So you are given with several points. You may have used an electric torch when you are going out at night. You can get more light when using an electric torch with more cells. Now, you know that in our environment, in our day-to-day life, there are different types of torch, right? There are different types of torches. There are different types of flashlights. There are smaller ones and there are larger ones as well. If you take the smaller ones, the number of cells that we can insert into a smaller torch is very less. Like less means it can be maximum up to 2 or 3, right? 3 is a larger one, right? Okay, if you can insert like 3 dry cells or 3 batteries, actually battery term is not correct for this thing. However, we use that thing in our common as our common verbal word, right? To indicate a dry cell. Actually, the correct word is dry cell. However, we can use batteries as well. I'll let you know what do you mean by a battery when we are discussing further things related with the lesson. So, however, you know that we can apply several batteries to a certain types of torches. So, when increasing the number of dry cells that we are going to apply, right? When increasing the number of dry cells that we are going to apply, the light of the torch also getting increased. So by applying several batteries or dry cells, we can get whatever the amount of light energy that we need. However, if the number of dry cells that can be inserted into a torch is the fixed value, then we can't change it, right? Means that if 2 pieces of dry cells can be inserted to a certain torch, then we can't increase that number. That's the case in here, okay? So normally, usually, these torches would come with a certain amount of dry cells which cannot be increased. In order to increase, we have to change the torch because the body of the torch is fixed. We can't change it. So, however, there are different sizes of torches. According to the size, the number of dry cells that we can insert into the torch is also getting changed, right? Okay then, so by increasing the number of cells that we used in a torch, my dear children, we can get more amount of light. So it's obvious. We can use a line of bulbs to illuminate the environment in ceremonial occasions. So in ceremonial occasions, right? In ceremonial occasions, you know, like if you take Vesak ceremonies, Poson ceremonies, sometimes in some kind of alms giving, right? In some religious activities, religious ceremonies, right? So we use different types of light bulbs in order to light up the environment. I think you know about the Vesak panels, right? And Vesak lanterns. All of these things, we use different types of light bulbs and we light up the environment by using those light bulbs, okay? So here in such occasions, color bulbs can be used to increase the attraction. So here to increase the attraction, we use different colors of bulbs. Then after that it is given, the bulbs illuminate because an electric source sends a flow of electrical charges through them. The bulbs are going to illuminate because you are sending, or we are sending, some kind of an electric charges through the bulb. These electric charges which travel from one place to another is called as an electric current. We identified this thing about the electric current and we learned about the electric current in the previous lesson also. So these electrical charges are called as electric current. So such a flow of electrical charges are known as, you know, electric current, right? So electric current means basically electrical charges which flow through a closed system. It should be a closed system. In a closed system, only the electrical charges will flow. These closed systems which the electrical charges are going to flow are referred as electrical circuits, right? So the path of an electric current is called an electric circuit, right? You know that path of an electric current, path or the closed system that's going to flow electricity. So it's like a path, no? So path of the electric current which is going to flow is called as the electric circuit. A voltage should be supplied to a circuit before the flow of current. Voltage is supplied by an electric source. So you know that in order to flow electric current from one place to another, like in a waterfall where water is at the top and that water at the top is going to come down with a certain amount of speed due to the potential energy stored in it. And upon the flow of water, that potential energy is getting converted to kinetic energy. That's how a waterfall is going to work, right? That's how the water in waterfall at a higher place is going to come down because of the energy difference, the potential difference created at the top and the bottom. So in the same way, we discussed that in a dry cell also, in the positive terminal, there is a high potential of electrical charges, and at the negative terminal, there is low potential of electrical charges. So when you are connecting a conductor from positive to negative, automatically these electrical charges travel from positive terminal to the negative terminal. We conducted several activities in the 8th lesson, my dear children. Refer that. So those things are really important before coming into this lesson. So once again, the electrical charges that runs through a path or that runs through a circuit is called the electrical current. In order to flow electrical current, there should be a potential difference. The difference between two terminals in a certain circuit, right? Difference between the electrical charges. Difference between the electrical charges between two terminals of a certain circuit is referred as the voltage. So in order to flow current, there should be a voltage, right? This is also referred as the potential difference. So in order to flow current, there should be a potential difference for sure, right? So those are the, actually in here, in the first slide related to the lesson, you are given with all the things. You are not here, it's not given about the resistance, but however you are given several things related to the earlier lesson under the measurements related to electricity. So especially here given what are the things which are referred as the, or what is the meaning of electric current, what's the meaning of a circuit, and in order to flow electric current, we studied that a voltage or else a potential difference is important. So a summary is given in the first part related to the electricity, right? So let's move on with the next one. Before that, there's another one which is given here. See? So a switch can be used to open or close a circuit when necessary. So you know that we can use different types of switches in order to open or close a certain circuit. Opening and closing means, here closing means closing down the circuit. So here upon closing, you know that electrical charges are going to flow. So electric circuit is also already, you know that it is a closed system. So in order to close the system, we use switches. And if you want, in order to open it, that means you need to have a chance, or you need to have a certain, if there is a certain case, you need to have a certain chance, or so you need to have a certain ability to turn off the circuit and turn off the lights or whatever the electric appliance that you are going to use in that, right? So in that case, in order to turn on or turn off, in order to open or in order to close, we use different types of switches. So under this lesson, we'll be discussing about those switches as well, right? So switch is being used to turn on or off a certain electric appliance in a circuit, right? Okay, so these are the main things given under the first part of your lesson. So here especially, it's given that here it is mainly it's given about the electrical charges or electrical current and the electrical circuit, then about the voltage, then finally about switches to get some idea how to open or close a certain circuit, right? So already we know these things, we learned these things in under the previous lesson, right? Now let's move on with the other contents in our lesson. So you are given with a Vesak panel and a torch, right? So here different kinds of bulbs can be observed with different colors, and also they are in different sizes as well, right? In some panels we use different sizes of bulbs. So this is a Vesak panel that we use to decorate our houses or in our streets during Vesak ceremonies. And this is the torch that we used in our day-to-day life to travel in dark. Okay, so all of these instruments are getting operated using electricity. Okay then. So to get a reminder about the electrical current and electrical circuit, let's write down what do you mean by electric current and the electrical circuit. So electric current means flow of electrical charges. It's a beam of electrical charges, right, that is traveling through a conductor or else through a circuit. So we can write a beam of electrical, right, a beam of electrical charges that travel through a circuit, So what do you mean by an electric circuit then? Electric circuit is the pathway or the system, the closed system that electrical charges are going to flow. So we can write the closed system or the path. The closed system or the path which electrical charges are going to flow. The closed system or the path which electrical charges are going to flow. The closed system or the path which electrical charges are going to flow is called the electric circuit. It's called the electric circuit. Is called the electric circuit. So, electric current, a beam of electrical charges, a flow of electrical charges that's going to happen within a conductor or else within a circuit. Then electrical circuit means the closed system or the path which electrical charges are going to flow, is called the electric circuit. So the closed system or the path which electrical charges are going to flow is called the electric circuit. This is the electric circuit, then this is the electric current, right? Alright then, let's move on with the next slide. So those are the basic things related with our lesson. Now we'll be discussing the first main topic related to lesson right now. Here we are specially discussing about the various methods of connecting cells and the bulbs. Here especially we are discussing about series cell system, series connection of cells, right? So under that you are given with an activity, making a series circuit, right? So we are making out a circuit, right? We are making out a circuit here especially that has a series connection, right? Now let's see what are the materials that we need in doing this activity. So here we'll be needing torch bulbs, right? We'll be needing torch bulbs. Then dry cells. Then we'll be needing switch, right? We'll be needing some switches. Then in order to connect these things, connecting wires. Then we'll be needing a voltmeter. Right? So these are the materials that we need when conducting this activity. We'll be needing torch bulbs, dry cells, switches, some connecting wires and voltmeters. Okay, right. Then you are given with a figure. Actually, there are three figures. Figure 1, in the first figure you can observe there is only the voltmeter which been connected with the electric bulb over there, and there is one dry cell connected to a switch, just one dry cell. Then in the second instance you can observe there is that torch bulb, then voltmeter is there, and there are two dry cells in the second instance. In the third instance, figure 3, you can observe the same diagram but my dear children, with 3 dry cells. Okay. So let's see what is the method in doing this activity. First, connect one dry cell with the bulb and the switch as shown in the diagram 1. One switch and one dry cell. Connect the voltmeter to measure the voltage across the bulb. Now, to measure the voltage across the bulb, we have to connect the voltmeter. Then connect 2 dry cells with the bulb and the switch as shown in the figure 2. Then after that, we have to connect 2 dry cells. Then after that, connect 3 dry cells with the bulb and the switch as shown in the figure 3. Right? So figure 3, you have to interconnect these things according to the third figure by connecting 3 dry cells. Then now close the switches of 3 circuits at the same time. Now you have to turn on separately, first of all, turn on and see what's going to happen. Then to get a more idea, close or turn on the switches of each circuit at once. By that way, we can compare the brightness and we can compare the readings in voltmeter, right? Then compare the brightness of the bulbs and record the voltmeter reading. Then fill the table according to your observations above, right? Now, table is given in the next slide, my dear children. I'll show it, but this is the structure, this is the method of doing our experiment. It's really simple. First of all, you connect the voltmeter to the two terminals of the bulb. Then you take one terminal and connect with the switch. Then after that, take the other terminal of the bulb, connect it with the tri-cell, and take the other terminal from the switch which is coming and connect it with the other terminal of the tri-cell. So simple. Then after that, what you have to do, turn on the switch and measure the voltage plus the brightness. Okay. Then what you have to do is you can use the same circuit. You can use the same circuit if you want. But however, at the end, we have to prepare all 3 circuits separately in order to compare the brightness and the readings. So it's better to use 3 different setups or 3 different circuits. Then in the second circuit, what you have to do, same thing like in the above, but you have to use 2 dry cells. In the third one also same thing. There is no difference, but you have to use 3 dry cells. Then after that, by looking at the brightness and taking the voltmeter reading, right, you can turn on the 3 setups at once to compare the brightness and to compare the voltmeter readings. So this is how we are going to conduct the activity. So my dear children, let's head on to the lab and we'll complete out this activity and let's see what are our readings. Okay, my dear students, now I'm about to conduct the activity which is given at the first and foremost in your textbook. Now, I have several connecting wires with me right now and I have a dry cell with me, right? So this is a switch and a torch bulb. So first of all, in order to see the brightness, by using a double tape, I am going to fix this thing on the stand so that you can see the brightness very well. Okay, then after that, what I'm going to do is I'm going to first connect the positive terminal of the dry cell with the switch here. Then after that, it runs to the one terminal of the bulb. Then the next terminal to here, the second terminal of the bulb. Then finally, that terminal to the dry cell. So I have completed my circuit now. So when I'm going to turn on the switch, the bulb should light up. Yes. So it's lighting up. You can see there's a very less amount of brightness. Okay. So now what I'm going to do is I'm going to connect. Here I have a voltmeter. Right. Now first of all, I'm going to connect the voltmeter for the two terminals given in here. So remember, when you are connecting these two terminals, the red one should goes to the positive terminal. See here, I have connected each red ones. These red terminals are the positive terminals. So I'm going to connect the red terminal with the positive terminal over here. And the black color terminal, the negative terminal with the black color terminal over here. We discussed these things in the earlier lesson also when we are discussing the features or measurements related to electricity. So now what I'm going to do is I'm going to turn on my circuit and let's see how much is the reading in voltmeter, and we're going to check the brightness of the bulb as well. Right, now I'm going to turn on this switch and let's see what happens with the brightness of the bulb plus the reading of the voltmeter. So actually we have to check the voltmeter first whether our scale is correct or not, right? So now here I have prepared it so that it would measure small currents, but however you'd already know that when I'm introducing the voltmeter at the 8th lesson, I told you that there are two scales in here, the 15 volt scale and here the 3 volt scale, right? We use these two when you plug in, when you take this plug out, and if you are going to connect it with this terminal, then here the scale is from 15 volts. It's coming from 15 volts as it is mentioned 15 in here. So there is no that much of voltage in this bit of a small tri-cell, so therefore we need to adjust this one once again to 3 volts. So I have make it into the 3 volt scale here. Now let's turn on the switch and let's see, my dear children, what our result, right? So I'm going to turn on this thing now. So you can see that the bulb is glowing. Bulb has some amount of brightness, right? See, you have some amount of brightness, and let's head on to the voltmeter reading and get a reading of the voltmeter. So here, don't look above, check the below reading, because that's the reading which is running through 0 to 3. So here you can observe 1, 1.1, 1.2. It's between 1.3 and 1.2, 1.3 and 1.4, right? Yes, 1.1, 2, 3, yes. Between 1.3 and 1.4 you can observe the reading, right? Between 1.3 and 1.4. So let's round off it and take it to 1.4 volts. So 1.4 volts, right? 1.4, actually it becomes 1.3 now, right? So we'll, as it is more near to 1.3, we'll take it as 1.3. Pretty much near to 1.3, my dear children. You can observe it here, pretty much near to 1.3. So we'll take the reading as 1.3. So when I'm going to connect one dry cell with the switch with the bulb here, the voltmeter is giving out a reading of 1.3 volts. Okay, and the bulb is showing small bit of a brightness only, right? Barely visible brightness can be observed in the bulb. Right, now what I'm going to do is I'm going to remove this dry cell, this one. I'm going to remove this. So I told, but you know that we have to actually prepare 3 set of circuits, but however the same circuit is being applied here. Only thing which is getting changed is the amount of dry cells. So my dear children, when I am going to conduct the activity, right, separately each time, I am going to use the same apparatus but with different number of dry cells. So now let's move on to the second setup. Now in the second setup, you have to use two of these, right? We have to use two of these. So I'm going to use two dry cells now. I have several prepared here with me right now. So I'm going to use now two of these dry cells together to get a certain reading, right? Okay. So two of these, let's connect and see what's going to happen. So first of all, you have to check the positive and negative terminal. So I'll show you. I have to insert it properly, otherwise there won't be any electric current flowing from the circuit. So the negative terminal here, then positive with here. Now the system is okay. So this is my negative terminal. So let's connect the negative terminal here. So I'm going to connect the negative terminal here. So I have connected it. Then the positive, I'm going to turn off the switch. Then the positive terminal to this terminal. So my children, there are two dry cells now. So let's turn on the switch now and let's see. Yes. So check the brightness of the bulb, children. The brightness of the bulb has got increased. It's showing a very good, I mean like it's showing a well brightness. Oh, brightness is pretty much high. When you take the previous case, right? So in the previous case, when I'm using just this one single dry cell, the amount of brightness or the intensity of the light produced by the bulb was very less. But however, when I'm using two of these, it's giving out a good brightness. And let's see the reading of this voltmeter. So it's near to 3 now, passing 2.5, 2.6. Yes, the value is at 2.6 now. See, it's at 2.6. So 1.3 was the previous reading. Now it has become 2.6. 2.6 volts. 1.3, 2.6. Okay, 2.6. And the brightness is pretty much high this time. Now once again, I am going to turn off my switch. Then what I am going to do is simple. What you have to do, you have to connect now three of these dry cells. So I have with me three dry cells, set of three dry cells right over here. Okay, so what I'm going to do is I'm going to connect these three to the circuit given in here right now. So positive terminal is here, positive with positive, right? Then negative with the negative terminal. So observe the brightness of the bulb. Okay, so let's turn on the switch and let's observe what's going to happen in this time. So observe the brightness, my dear children. Now the bulb is glowing at a it's emitting very high amount of light, right? Intensity of the light produced is very high. Brightness is very high. Let's go for the reading of the voltmeter. Now it has passed. See, even we can't get a reading from the 3 volt scale now. We have to change the scale to 15 volts. So I'm going to turn off this thing right now and I'm going to take or eject this terminal and I'm going to place it at 15 volt scale. See here 15 volt scale is given. Now the reading is from the scale is from the top one. Okay, then let's turn on and get a reading. Once again it's showing a good brightness and we'll see how much is the reading now. So check the top one. Okay, Here it's nearly, now here to here there are 5 units. 0 to here there are 5 units, right? So there are 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, here to 5, then 6, 7, 8, 9 and 10. So there are 10 units from 0 to 5. Means that each unit is giving half. Each unit is giving half of volts, right? As there are 10 smaller divisions. So let's count here to here 5. 5 means 5 times half, 2.5 volts. Then how many volts are there? 2.5, 3, 3.5, 3.5, then 3.5, 4. There are like 8 units. Count 8 units from 0 to this. There are 8 units. See, 1, 2, 3, 4, 5. Here you can observe a larger line. That's the midpoint of 0 and 5, which is 2.5. So let's count 2.5, 3, 3.5, 4. So my reading is now 4 volts. My reading is 4 volts. 4 volts. Okay. So first 1.3, second 2.6, now 4 volts. So here it's obvious to us that when I'm going to increase the number of cells, when I'm going to connect these cells in a series connection like one after the other, the voltage given out by the system or the voltage given out by the system of cells or the battery is going to increase gradually. Right, so I'm going to turn off this one right now. So let's turn off. Now what I'm going to do is I'm going to prepare all of these 3 circuits at the same time to get the necessary readings. Okay, my dear children, now I have prepared the 3 setups. Okay, so I have setup number 1 here with 3 dry cells. So to compare the brightness quite more easily, I have taken a separate holder so that it would keep rigid in our desk. Okay, so the 3 setups of bulbs with the holders, then 3 voltmeters, then here you can see a switch, here also the second switch, right? Here the second switch. Okay, then as for the third one, I have taken a different type of a switch. This is called as the plug key. So you just need to insert this plug key into this hole in order to complete the circuit. Okay, it's really simple, right? A type of a switch. So just insert this plug key into this hole here. So by that way we can complete the circuit. We'll be discussing about the plug keys under the switches part. Okay, right, so I have prepared 3 circuits in here. First one with 3 dry cells at my left hand side, second one with 2 dry cells. In the middle you can observe that one. This is that bulb. This is the bulb of the 3 dry cells one, and 1 dry cell. See, 1 dry cell, and the voltmeter and the bulb of that one. Okay, now let's turn on the switch and see. There is a small bit of a thing to inform my dear children. It's that now usually when we are taking smaller voltage readings, you know that you have to take the scale here to the 3 volt thing. But the one is that now here at the third incident or at the third instance, I have used the 15 scale. No, otherwise we can't get a reading. So you could observe that the reading was at about 4, right? In the third instance when we are using it alone. So by using the 3 volt scale, we can't measure 4 volts. So therefore I have arranged it to the 15 volt scale. So in each of these ones I have arranged to the 15 scale so that the external factors would never going to change. When we are doing some kind of an experiment, we have to keep our external factors in the same stage. So I have plugged in each of these instances into the 15 scale, as I have plugged the third instance from 15. So these two are also in the 15 scale, right? So when you are getting readings, you have to check the 15 scale, okay? Right, so let's turn on each of these circuits and let's see what's going to happen. First one, then I told you that I'm going to use the plug key in the second one. So let's insert the plug key. Number 2. Then the third one. Here we go. So observe the brightness in each instances of the bulbs. Less brightness, more brightness, very good brightness, or very high brightness. So brightness is gradually increasing when you are increasing the number of cells. Cells 1, 2 cells, 3 cells. Right, now let's go for the readings in voltmeter. Once again, check the 15 scale. So here 1, 2, 3, nearly about 3 units, right? Nearly about 3 units at the first one, right? Nearly about, starting from 0, in here you have to check. So nearly it's about 3 units. So 3 units means about 1.5 volts. Can you remember we took the reading as 1.3? So here 1.3, right? 1.5 is also correct, no problem with the 15 scale, but we'll assume that one as 1.3. Then the second one, this thing. In here you can observe the reading at 2.5 scale. 2.5 scale. So we took the reading as 2.6. However, near to that value, 2.5 can be observed exactly, right? 2.5 scale can be observed exactly. Then the third and the final one, this one, it's very closer to 5. However, 2 units are behind. So the reading in third one is 4 volts, right? 4 volts. 4 volts. So 1.5, 1.5, let's take that one as 1.5. We'll round off that value as 1.5, right? So this one 1.5. After that you can observe 2.5, 1.5, 2.5, then finally 4 volts. Brightness, very less brightness. Some kind of a medium amount of brightness means that greater than this one but less than the third one. So second one has a like medium amount of a brightness in a mid range. Third one has a very good brightness over here. So these are our observations from the activity, right? So let's head on to the classroom once again and we'll write down our observations and let's see what are our conclusions about this activity, right? So remember to keep in your mind about the readings and how the bulbs are going to glow, right? So we need to complete out a table. You could remember that I told you that there is a table. So we need to complete that table. So remember about the readings. 1 point, we'll assume that this one is 1.5. Actually we got 1.3. However, in the 15 scales showing 1.5. Here 2.5 and finally 4 volts. Right then, so let's head on to the classroom once again, children, and we'll complete out the table by using our observations. Right, my dear children, now we conducted the activity and we got our results. So let's tabulate the results according to this diagram, or the table given in the observation column. So let's fill out this thing first. So circuit in figure 1. In the figure 1 we used only one dry cell figure 2, 2 dry cells, and in figure 3, 3 dry cells, right? Voltmeter reading was 1.5 in the first, 2.5 in the second, and 4 volts in the third. Brightness in here very less, very high, then in here more than 1, less than 3. More than 1 but less than 3. Okay, brightness. Right? So these are our observations. So what is our conclusion? So by looking at this activity, we can say that when these cells are connected in a series connection, the voltage is getting increased from 1.5 to 2.5 to 4. And the brightness is also getting increased because of changing or because of increase in the current flow, right? So that's why under 1.5 very less brightness is given, under 2.5 more than 1 but less than 3 brightness is given, under 4 very high brightness is given, right? So we can write our conclusion. When cells are connected series, you can say that number 1, voltage increases. Number 2, current flow also increases. Right. So when cells are connected series, right? When cells are connected series, you can say that voltage is going to increase and current flow is also going to increase. We can say that the current flow is going to increase by checking the brightness of the bulb. Okay. So my dear children, this is the activity under the series connection of cells. So when the cells are series connected, like in the figure, like in the activity that we have done here, you can clearly say that the voltage is going to increase and the current flow also going to increase. That's why the brightness of the bulb is getting increased from very less to very high, and also the voltage also getting increased from 1.5 to 4 under 1, 2, 3 cells. Right then, so let's see what are the other contents in our lesson. Okay, my dear children, now we conducted the activity and you know that, and we identified that what's going to happen when you are connecting several cells together, right? So the explanation is once again given. It can be observed that the brightness of the bulb increases when the cells are connected, as in figure 1, 2 and 3 respectively. So you can already I written down these things, right, using the readings as well. Then when the number of cells are increased, the voltage increased, hence the current is also increased. So when you are increasing the number of cells, the voltage provided is going to increase, and therefore the current is also going to increase, my dear children. So by increasing the potential difference or the voltage, we can get a more amount of current. You know that if you take normal dry cells, in normal dry cells like AAA size dry cells, in normal dry cells, the potential difference or the voltage is just 1.5 volts. So it's not lethal at all. Even we can use our arms in connecting these instruments to a circuit that has these dry cells. It's because that the potential difference given is very less. Therefore, very less amount of current is going to flow. But what happens when you are coming into household electric circuits? In household electric circuits, there is a potential difference of 230 volts. So compared to dry cells, it's about like 20, right? Like about 20, right? It's about 20. Let's say roughly it's 20. It's not actually accurately 20, right? Let's say roughly like 20. So 20 times means, right, it's actually more than 20 times, right? It's greater than 20 times. So let's calculate and see how much is the difference. So you know that I told you that 230 volt is the potential difference in our household electricity. In normal dry cells, the potential difference is just 1.5 volts. So in order to get the number of times, we need to divide 230 by 1.5. So here you need to multiply this one by 10 and here also by 10. So 2300 by 15. See? Let's see. Then 1. There is a remainder of 8. For 80, there is 5, right? 75, 5 is remaining. Then 3. Roughly there are like 150 times. It's not 20 actually. 7 times of 20. Greater than 7 times of 20. See? Now we got an idea how much larger than how much times our domestic electric circuits have a potential difference when you compared it with the normal dry cells. It has like 150 times. 150 times. So 150 means a very large amount of electricity is going to flow. Right? Very large amount of electricity is going to flow. So my dear children, that energy or that current is very lethal to us. Can be dangerous. Even the people may die if you are going to get an electric shock related to the household electric circuits. So that's what the potential difference can do. If the potential difference is low, then the current also flowing from that system is going to be reduced. It's like a waterfall. I told you that potential difference is like a waterfall. High the waterfall, the rate of water which is going to flow from top to bottom is very high. If you take the Niagara Falls, large amount of water is coming down with a huge speed. It's because the potential energy carried out by the water is very high because of the height. So in the same way, when you are connecting several cells together, the potential difference created between the two terminals is going to increase gradually. By that way, more amount of electrical charges is going to flow at a higher rate. So therefore, the current that we can take is going to increase when you are increasing the number of cells. That's why in a torch also, when you are increasing the number of cells, the brightness is going to increase because more current is flowing towards the bulb, right? So I'm going to erase these things just to show an idea. What do you mean by I took this idea example just to show how much times is our domestic electrical circuits compared with a normal dry cell. So here it is given that, see, When the number of cells are increased, the voltage is increased, hence the current is also going to increase. When required voltage for an electrical equipment cannot be supplied by a single cell, several cells are connected as in the figure given, right? So let's imagine that there is a torch bulb. On the torch bulb, it's been printed as 7 volts. You know that there are different types of torch bulbs. Let's imagine that 7 volts is being printed. So say in order to operate, there should be like at least like 7 volts. In a normal dry cell, there is 1.5. So what we can do is, we can get like several dry cells, right? We can get several dry cells, like 5 of them, and we can interconnect these things. So by that way, we can light up the bulb, okay? So if the necessary requirement or the necessary voltage is not getting produced by a single cell, in that case we can use several dry cells, like in the figure here. So here there are three dry cells interconnected each other, and that over there you can observe the circuit diagram for series connection of cells. So when you are drawing, my dear children, don't draw it like this, because most of the students are drawing like this. So there are 4 dry cells in this setup. But it's not correct, it's not accurate. How come? What is the reason? Because in order to flow electric charges through the dry cells also, they should be interconnected to each other. So here this is one dry cell. Now I'll use a different color pen. Most of the times you will be definitely drawing these things like this, right? So even when I was in your age, I also drew it like this. So this is one cell. This is one cell, right? But can you see that there is no connection between the second cell and the first cell? So if there is no connection, electrical charges will not be able to travel from this particular terminal to the next particular terminal. So my dear children, it's important to interconnect. So I'm going to remove these things now. It's important to interconnect these terminals together, like in the figure here. See, this negative terminal with the other positive terminal. Now these 2 dry cells are connected. Then this negative terminal once again with the other positive terminal. Then here. So like that way, you have to interconnect the cells. Otherwise it is wrong. Wrong means it is an open system, right? If the dry cells are not interconnected to each other, how the electricity is going to flow? So remember to interconnect these things when you are drawing out a series connection of cells, okay? So remember to interconnect like this. So like that way, like here you are given with 3 dry cells which are interconnected to each other. Here I have drawn 4 dry cells which are interconnected to each other. So don't draw it like this. If you draw it like this, it's wrong. Don't just put the symbols like this. It's wrong. Okay, this is wrong. Remember to interconnect these terminals. Interconnecting means here negative with the positive, once again negative with the positive, like this. That's it. Okay, remember to interconnect. So this is the way of connecting cells in a series connection. So by connecting cells in a series connection, we can increase the voltage, plus we can increase the current as well. Okay then. So in this connection, negative terminal of one cell is connected to the positive terminal of the next one. So you know that, right? When you are interconnecting these things, negative with another positive terminal, right? The negative terminal of second cell is connected to the positive terminal of the third cell, and so on. So like this way, the figure is once again given. When 2 or more cells are connected one after the other, it is called a series connection. So series connection means one after the other we have to interconnect terminals. So if one thing is going to be removed from the system, the whole system is going to break down, right? So that kind of a connection is referred as the series connection, my dear children. Even we draw figures, right? So in this lesson also we are going to draw several circuit diagrams as well. However, you know that what do you mean by a series connection. So in a series connection, remember we have to interconnect, like there are two terminals in any kind of an instrument, no? So one terminal should be connected with the other terminal of the second. Then one like that, one to one, we have to connect to a certain type of a line starting from 1 to the end. So after that, first terminal, last one, second terminal, connected into a circuit or connected into electric source. So that's how we connect instruments in a series connection. Then it is given once again, therefore such a cell system is known as a series cell system. So this is a series cell system, right? Series cell system. Such a series cell system is known as a battery. Now I told you that in the earlier parts when we are discussing about the lesson, dry cells are usually, in our normal common verbal conversations, we refer dry cells as batteries. But however, it's wrong. In our normal day-to-day situations, we can use it. It's not a problem at all. But however, when you go to the scientific clarification, it's somewhat different. A battery means series of cells which is interconnected each other. A battery. So battery is going to provide more amount of electric current and a voltage. So it's not wise to use the term called battery for its just single dry cell. So when you connect several dry cells together like this system is called as a battery. However, in our normal verbal conversations, we use this ones as battery as well, right? But remember, scientifically, the explanation for a battery is series connection of several dry cells. Okay then. So, in the next one, we'll be discussing about parallel cell systems, right? So, now we got a sound knowledge about the series connection thing. Now we are discussing about parallel connections, okay? So, let's see. Other method of connecting cells in a cell system is shown in figures 1 and 2. And now here, my dear children, each of the dry cells are interconnected each other positive with positive, not like in the earlier case. In the earlier case, we connected positive with the negative one and that negative one with the again positive one. But here, all the positives are interconnected each other. See, all the positives are interconnected each other. All the negatives are interconnected each other. So this type of a connection is called a parallel connection. This type of a connection is called parallel connection, right? Most of you guys think that, okay? Most of you guys think that. So I'm going to give you a simple question and I'm going to ask you a simple question right now. So you have observed what do you mean by a series connection and what do you mean by a parallel connection, right? Okay, so I'm going to ask you a simple question. So I'm going to use cells here. So this is figure A. Let's connect it with the bulb. This is figure A. And children, I'm going to draw out another figure. This is figure B. So my question is, out of these two figures, out of these two figures, my question is really simple. Out of these figures, so there is a small bit of a correction here, right? So my dear children, my question is, out of these figures, which one is parallel and which one is series? Right? Which one is parallel and which one is series? There are two figures. So most of you guys are going to go for the answer like this. Now these things are connected like in a line, no? So definitely this is series. And now when you check these things, this cell is at the top, this cell is at the bottom, like they are connected in a parallel line. That means this one is parallel. This is parallel. This is entirely wrong. Okay. Both of these systems are series connected. Both the systems are series connected. There is no parallel connection. How can you see that? By looking at the circuit diagram. That's how I am going to say it. But in here the two cells are parallel to each other, no? Then how come it would be series? Dear children, now when you are checking about the series and parallel connection, it's not going to, it's not depending on the way that these cells are being placed. It's not going to depend on that factor at all. Right? Parallel and series connection is going to depend on the way the dry cells are being interconnected to each other. How these are being interconnected to each other. So I told you that if a certain positive terminal is getting connected with the negative terminal of a certain other type of a cell, like in here, see, negative with positive, this is negative, this is positive. You know that the longer terminal is positive and the shorter is the negative one. So negative with positive. Check in this one also. Let's see, let's go. So this is negative, this is positive. So negative is coming with the positive one here. So this is definitely a series connection. However, the two dry cells are placed parallel to each other. That's correct. Their position is parallel to each other. However, the connection is series because the negative terminal is interconnected with the positive terminal. Then check with the bulb once again. First terminal is connected to the positive terminal of the first dry cell. The second terminal over here is connected with this one is connected with the negative terminal of the second cell. So in a series connection, my dear children, one terminal is coming from one electric source or one type of a cell or one type of a terminal. The other terminal is coming from the second one in a series connection. That's how a series connection is going to work. So don't mess up these things. Don't think about their pattern or the way they are being placed. We are not going to check that thing at all. Remember, we are checking whether the terminals are connected in an opposite way. Like when you take the first one, it should connect with the other one. But however, in opposite directions, like if positive is connected with negative, then it is a series connection. Now in the figure given above, so I'll draw a parallel connection as well. So this is, I told you that this one is incorrect. Okay, this is not a parallel connection. This figure, this is incorrect. It's not a parallel connection. Definitely that is also a series connection. This is also a series connection. Right, so I'm going to draw out a parallel connection to show in the same figure here by using two different dry cells. See, take the positive terminal and the negative terminal, connect the positive terminal of the first one with the positive terminal of the second one, like this. This is the way. Okay. So, in this case, my dear children, the specialty is that if you connect the bulb like this, if you connect the bulb like this, right? If you connect the bulb like this, the circuit is useless. Then, in order to get a use, how do we need to connect? Get a use, we need to connect not like that. We have to first of all interconnect the two other terminals as well, like this. Then by only we are going to connect in a different place, like this. This is a parallel connection. See, negative terminals are interconnected at these nodes and run towards the bulb. All the positive terminals once again interconnected to each other at the nodes and run towards the bulb. This is a parallel connection. So, however, by looking at these two figures, you might get an understanding or you might get a wrong conclusion that is also parallel. But don't look at the figure, just look at the way how the cells are connected to each other. If one cell is going to connect with the opposite terminal of the other one, then it should be a series connection. If all positive cells are connected to each other and all negatives are connected to each other, then it is a parallel connection. Series and parallel. Don't get confused, okay? Right. Don't check the way they are going to place, but check the way that they are connected to each other. That's the better way of finding out whether the connection is series or parallel, right? So once again, we'll come to see the parallel connection. Right, so it is given in this connection, positive terminals of all cells are connected to one point and the negative terminal of them are connected to another point. A connection like this is called a parallel connection. Such a cell system is known as a parallel cell system. Parallel cell system. Right. Then once again, you are given with an activity. Within this activity, we'll be checking what's going to happen in a parallel cell system. In series cell system, we earlier discussed. Now here we are going to discuss about what is going to happen in a parallel connection of cells. Okay, so let's see. So studying about parallel cell systems, activity making a parallel connection circuit. So you'll be needing once again these materials. What are the materials? We'll be needing torch bulbs. Right? We'll be needing torch bulbs. Then after that, we'll be needing switches. Then wires, connecting wires. Then the most important thing, dry cells in order to provide electricity. Dry cells to provide electricity. Okay. So these are the materials that we need. So like in the earlier case here, we are going to take one cell connected with the electric bulb here. Then we are going to take two cells, but the connection should be parallel to each other, right? Like that, if you want, you can connect three as well, right? And we are going to check what is the brightness. And you will be needing several bulbs as well to check the brightnesses of the bulbs. Let's see how to conduct the activity then. So once again, you are given with three figures. Figure 1, figure 2 and the third figure, right? Figure 1, figure 2 and figure 3. So first connect one dry cell with a bulb and switch as shown in the figure 1. Okay. Close the switch and observe the brightness of the bulb. So you have to close it and observe the brightness. Right? Figure 1. Really simple. Then connect the cells to the bulbs and the switches as shown in the figure 2 and 3 separately. Close the switches in each instance and observe the brightness of the bulbs. So here there are two dry cells interconnected each other in a parallel connection. Here there are three dry cells interconnected each other once again in a parallel connection. How can you say whether it is a parallel or series? Because check the way they are connected each other. Two positive terminals with one terminal, two negatives with the other. So it's a parallel one. Here also 1, 2, 3, all three positive terminals interconnected each other. 1, 2, 3, all three negative terminals interconnected each other. So it's once again a parallel connection. It's really easy to identify the connection systems if you check the connection method but not the arrangement of the cells. Okay, right. Then after that you are given close the switches of all of the circuits as shown in figure 1, 2 and 3 at the same time. Compare the brightness of the bulbs. So, like in the earlier case, at the same instance, we need to close all the switches and we need to observe the brightness. So, this is the way of conducting the activity. First, you prepare this one, turn on the switch and you are going to observe the brightness. Then you are going to prepare this one, observe the brightness. Then you are going to prepare that one over there, the third figure. Then observe the brightness. Okay. Then get all three at once, turn on all the switches and observe the brightness of the bulbs. Okay. So this is the way of conducting the activity. So my dear children, let's head on to the lab and we'll conduct the activity and let's see what's going to happen. Okay children, now we are going to study about the parallel connection of cells. What happens in parallel connection of cells? So in the earlier case, I prepared each of the circuit in front of you. But now in these setups, I have prepared it already. Now all I need to do is turn on the switches. So, but however, I'll show you how did I connect each of these circuits given here, right? So first of all, let me separate these three so that you can observe clearly. So this is number 1. See, this is number 1. So this is the switch. One terminal is connected to the dry cell. The other terminal runs to the bulb over here. Then the second terminal of the bulb comes to the dry cell. So here one dry cell, one bulb and one switch. The second one, here I have used the plug key like in the previous case. My bulb and two dry cells which are parallelly connected to each other. And here the third setup, once again you can observe the switch, 3 parallelly connected dry cells, a bulb. So connecting wires in connecting each of these stuff together. Now what I'm going to do is I'm going to first of all turn on the first circuit. See, right, first circuit. Then I'm going to turn on the second circuit by inserting this plug key. Second one. Then the third one over here, number 3. Right, so when you check the brightness of each of these bulbs, I can't see a huge difference in their brightnesses. Actually, when I'm observing it very clearly, I could see that nearly their brightnesses are equal to each other. Brightness of these bulbs are nearly equal to each other. Even though when I'm going to increase the number of cells which are connected parallel to each other, the brightness of the bulbs are not getting changed at all. Brightness remains the same in each of the instances. So my dear children, we can come into conclusion finally by observing these things. So if more amount of brightness is given, like in the previous activity, we can say that more amount of current is given out from the dry cells towards the bulb. That's why it is glowing up, giving a high brightness. But in each of these instances, you could see that their brightnesses are nearly equal. So means even the 1, 2 or 3 cells, if they are connected parallelly, same amount of voltage is given to each of these bulbs, no matter the count, right? So my dear children, during a parallel connection, voltage across the bulb is not going to change at all. It remains the same at a constant value. So let's head on to the classroom and write down our observations and the conclusions that we can take from the activity. Okay, my dear children, so we conducted the activity and you could observe that brightness of the bulbs are not going to change at all. So if you interconnect these cells parallel to each other, their voltage is not going to change. Voltage would remain the same. The same voltage is going to flow towards the bulb, right? If it is 1.5 volts, 1.5 volt is going to flow through the bulb. No matter you are connecting like 10 or 15 dry cells, however, right, the voltage across the bulb is 1.5. That's it. But it is going to depend on the battery. I just told you as an example. That's it. Okay. So we can say it like this. Observation is quite simple. What is that? All bulbs had the same brightness. All bulbs had the same brightness. So conclusion, what is the conclusion from this activity then? Conclusion is also really simple. When interconnecting cells parallel, right? When interconnecting cells parallel to each other, their brightness is not going to change. So therefore, we can come into a conclusion that voltage across the bulb is not going to change at all. So we can write brightness of bulbs did not change because there is no change because there is no change in voltage in the circuit. So let me rephrase this thing. In each, because there is no change in voltage in each circuit. So in each circuit, there is no change in voltage. All the voltages are same. That's why, my dear children, they are providing same amount of brightness. Okay. So all bulbs had the same brightness. That was our observation from the experiment. Then brightness of bulbs did not change because there is no change in voltage in each circuit. So in each circuit there is no change in voltage. That's why it's going to show out the same brightness. So once again, the explanation is given in this slide, my dear children. See, the bulbs illuminate in more or less the same brightness in all the three instances mentioned above. Thus, the current flowing through the bulbs is equal. So you know that when voltage is not going to change, the current is also not changing at all. When cells are connected in this manner, each cell supplied less current, but the collection of current supplied by cells is equal to current supplied by one cell. Therefore, bulb can be lighted for a longer time when cells are connected parallelly. So you know that each and every dry cell is going to provide same amount of voltage. So when one dry cell is going to dry up, the other one is going to provide electricity. When that one is also going to dry up, the third one is going to provide electricity. So like when you are connecting these cells in a parallel connection, you can light up these bulbs for a longer time period. Now in the earlier case, what's going to happen? Charges are going to flow from one battery to the other, then from one dry cell to the other in the battery, then from that dry cell to the other. Charges are flowing like a river from one to another, from one place to another, first to the second, second to the third. So at the same time, all the charges of all the dry cells are being used up. So in a series connection, right, the three dry cells are going to dry out at the same time. Okay. But in here, the three dry cells are going to dry out at different times in time intervals. First one is going to dry up, then second, then the third. Means that we can use this circuit for a longer time period rather than in the previous case in a series connection. But however, more brightness is given when it is connected in a series connection because more current is there. So once again you are given when current should be supplied for a longer time to an electric equipment, parallel cell systems are used. Now in our day-to-day life, in our common household electric circuits, we use parallel circuits, right? Because we don't know when you are using an electric appliance, when we are going to turn it off. So we need to provide electricity for a longer time period. So thereby we are using parallel electrical circuits in our houses. So my dear children, I hope that you got a knowledge about the cell systems, right? About the series connection of cell systems and about the parallel connection of cell systems. So these are the two ways that we can connect cells together. Now in the next chapter, let's discuss about bulb systems. So till then, it's time to say goodbye.